Hello, everyone. Welcome to another Observable Lightning Talks. In fact, the September 2025 edition. I had some issues with the platform. I have some problem with the graphics, but that's what happens sometimes when you have relying on external systems. But never mind. Welcome to this live stream. I hope that you will enjoy this session. I'm very excited about the lineup of today. If you've been following the Observable Lightning Talks, I try to organize them about once a quarter, and I try to cover different themes like observability, security, open telemetry, Kubernetes. I mean, the type of topics that we usually cover on the channel. And today I'm very excited because we're going to focus very narrow down on observability in general. So I hope that you will enjoy today's session. So if you're connected, then let us know where you're connecting from. So I'm currently connected close to Marseille in Toulon, and the weather is beautiful today in September. So I'm enjoying the we'll say the end of the summer from this region. So let's know where you're connected, and if you during the session you will see that if you never heard about the Observer Lightning Talks, I will have to remind how it works. The way it works, usually you have two main sections. The first piece is three lightning talks, meaning that we will have three speakers delivering each of them a 15 minutes session. And to respect on the actual duration of the live stream, I won't take any questions from there. So you can drop your questions on the chat, no worries. So you can use LinkedIn or YouTube to drop your questions. And then we will have at the end a dedicated session where it's going to be a panel discussion where I will ask my questions, and also if you have any questions, we will um, ask them during the panel discussion session. So be patient, listen, take notes, drop questions. It's here all about chatting at the end and interacting with all of you connected today. So what is the agenda for today? Well, a couple of things. So today I have the honor to cover three great speakers and three great sessions. So first I have Ray Jenkins. If you followed, I released a video on Open Source Summit, and I had the chance to listen to one of the talk about Rotel. So you may say, what is Rotel? Well, it's the open temperature collector written in Rust. So if you have never heard about it and you've never seen about it, this is going to be a great session, a way of looking at this solution, see what you can do with it, have an idea of the power of Rotel behind the scenes. So that would be the first session. So ingest, first piece of the observability journey. So ingest data. So you need a log agent, and then Cyan. So very excited to have Cyan here. He's been very active in the social networks, doing a lot of things with Kube Simplify. Very active on SynCF. So I'm super excited to have him today. And he's going to cover Percy. So once we have data stored somewhere, we need to visualize it. And Percy is, if you never heard about it, is an open source project, part of CNCF, that provides you some. I won't tell you more. You will see. Cyan will explain you everything, and so you will have a lot of details about how you can visualize your data using Percy. And last, Nathan from Robusta. You know him. He's been already in this live stream several times. And he came up with a solution a few months ago called Homes GPT. So if you have data and you visualize it, maybe you want to take advantage of LLM to drop your questions and let the solution Homes GPT interact with different MCP servers and get the response that you need to troubleshoot. So if you're into using LLM to analyze your observability data, Homes GPT will be a great session. All right, so let's start with the first journey of observability, which is ingest, covering with Rotel with Ray. So let me up. Here it is. Hey, Ray, how are you?
Hey, Henrik, I'm doing well. How are you?
I'm good. Where are you based? I don't remember where you're based.
San Francisco. That's why the coffee. It's early here. It's 8.
Yeah. I said good evening. I said good morning, good afternoon, or good evening. That's true, because depending where you're connected from, it could change a lot. So
Yeah,
how is the weather so far in San Francisco? Is it good? Still good, or is it?
it's just gotten hot lately. Yesterday was 80 something, so I'm in the Mission. It gets pretty hot here, but overall it's been a pretty cool summer, so can't complain.
Okay, cool. All right. So, like I said, very excited to have you today for this live stream. I had a chance to see a pinch of your product during Open Source Summit, so I'm
Yeah.
very eager to see more and get more details. So I'll leave the stage to you. So you have 50 minutes, and see you in 50 minutes then.
Okay, cool. Yeah, I'm excited to be here. Let's talk about Rotel.
Cool.
Right. Yeah, so we're going to talk about Rotel. The title of this talk is Easy, Fast, and Efficient. Really, it's like the idiom, cheap, fast, and good. Pick 2. Well, with Rotel, we're trying to actually pick 3 in this case. So, and a little bit about, as Henrik mentioned, Rotel is for ingest and open telemetry collection. This is the team behind it, myself and my co-founder, Mike, who's not on the call today, but we met back at Librado about a decade ago, and we've been working on observability for decades. And we've also worked at some of those companies you see below, Snowflake, Netlify, and Segment. So yeah, a little bit about the Rotel project. So what is Rotel? Rotel is an open telemetry collection data plane. As Henrik, I think, mentioned, it's written in Rust, and we chose Rust primarily for performance and safety. We have written C++ before in the past. We considered writing it in C or C++, but we were kind of excited about the lack of UB and just the safety benefits with Rust. And after a little bit of experimentation, we liked it, so we continued on with that. We started Rotel probably about, I think, 8 months ago, and we announced it a few months ago at the Open Telemetry Community Day. It's open source, Apache license, very small image, and it's Open Telemetry native. And by that, I mean that internally the data model inside of Rotel is Open Telemetry. So when you're working with any piece of data, and if you're familiar with the Rotel data model, you'll be working with that. So some of the highlights of Rotel is, and what makes it a bit more unique, is that it has a Python processor SDK. Python's a nice, concise, powerful language, and we basically have extensions back into Rust, so you can write processors in Python, and we'll take a look at that in a bit. And we also really sort of focus on the DX, trying to think about how can we make it easier for people to adopt Open Telemetry and deploy it sort of anywhere. So out of the box, we also ship with built-in pipelines, so you don't spend a lot of time fiddling with that. Built-in batching and retry mechanisms. You can, of course, tune them, but it's sort of in there out of the box. We also, have an interesting different approach to deploying this and shipping it. So we ship pre-built modules for different runtimes. We're going to take a look at that. Pre-built containers, processors, and we have a growing set of receivers and exporters. So where do I run it? Probably most of the people on this call are familiar with the concept of collection and moving it outside of your application. But if you aren't, basically Rotel runs as a separate binary process. It can collect open telemetry coming from an SDK, coming from another sort of collector. It can also read open telemetry coming from Kafka, so it has a Kafka receiver. It can be forwarded from Kubernetes. Henrik and I were just talking about giving tracing and API server in Kube. And then on the exporter side, we have support for sending to any observability backend via OTLP, that's gRPC or HTTP, writing a Kafka, Datadog for traces, ClickHouse, writing a Parquet files, AWS X-Ray, and a couple other AWS services. So a little bit about why we did it and what are the sort of goals behind the project. We think and we believe that telemetry must be fast, efficient, and reliable. It's critical as we're seeing more and more, and we're going to talk about this, places where open telemetry can be deployed. It's important that it meets these criteria for performance and reliability. But we also feel like the developer experience shouldn't suffer just because we're trying to build something really, really fast and efficient. It should be really easy for people to pick up Rotel or Open Telemetry and get it integrated in their app really quick. And we also believe that you should be able to collect open telemetry data anywhere. So, particularly if you're in like really resource constrained environments, um, high performance environments, you shouldn't be limited by a tool that's going to stop you from adopting OTel because the performance isn't great enough or the resource efficiency isn't great enough. And that was the ideas behind starting Rotel. Just a little bit of just a look back. I think it's worthwhile to take a look at the timeline of some popular collection projects, and I don't have them all here. I just listed some popular ones. But as you can see, it's been a bit since something new has come out, and we think that there's room to innovate here. So as we go into the rest of the talk, we'll talk about those places where we're innovating. So. One common complaint we hear from a lot of people is that open telemetry is inefficient, and that can be in terms of the data model itself, can be repetitive or sending extra data over the wire, can be performance of collecting the data at scale. It can eat up a lot of RAM, a lot of CPU. If you're just doing, a few million things a day or even a billion things a day, it's not necessarily a big problem. Where you're getting in the, billions of things a second, and higher, hundreds of billions of pieces of machine data, resource utilization and efficiency sort of becomes paramount. So this is some charts that we publish on our GitHub. We have an actual repo, and it shows basically the efficiency of Rotel. And what these charts are is we're basically using the Open Telemetry Go collector, the reference implementation load test, and the benchmarks, and we run those against OTel, the OTel collector, and then against Rotel. And as you can see, basically for those workloads, for traces, logs, and metrics, Rotel uses about 75% less memory and about half the CPU. And for many workloads, of this level of efficiency actually translates into massive improvements, orders of magnitude improvements in throughput per core. My co-founder is going to be speaking next week at a ClickHouse meetup, and he's going to talk about Rotel performance. But for example, we see 10x, sometimes 15x performance throughput in writing the ClickHouse with Rotel. So this level of efficiency essentially allows us to deploy Rotel in environments where resource constraints are very high. And one of the places where it's become really popular is in serverless environments. So, and one of the important constraints in a serverless environment is collection agents have to start very quickly. Otherwise, they can affect the latency of an application. So we have a Rotel distribution that runs in Lambda, and it's prepackaged. It's easy to integrate, and basically the start time is about 60 milliseconds. And so we have a bunch of users using this in production. There is a Open Telemetry collector distribution for AWS, but the cold start times can be quite high. They can be upwards of a second in some cases. So Rotel's had a good amount of success working on the edge in those resource constrained environments. We also think anyone who's hyperscaling or running sidecars at scale, it's a great place for that. Just even small improvements in efficiency and performance yields big cost savings. Coming from places like myself, coming from Snowflake and Segment, when you are basically running at a scale where you are maxing out network interfaces and you are just processing a tremendous amount of data, you can't allocate 10% or 15% of a host's resources to telemetry. You really need something that's very lightweight and can run in these environments. And then there's also interesting use cases for Rotel in embedded systems, autonomous systems. We've had a lot of people contact us and inquire about using it and have used it in robotics platforms, drones, robotaxis, these sort of environments. The telemetry collection needs to be very lightweight, it has to be very reliable, and it has to have basically predictable latencies. And so Rotel, written in Rust without a garbage collector, is able to satisfy a lot of these requirements. One other, so we've talked about the performance stuff. Let's kind of shift gears and talk about the DX side of it. Another complaint that we hear often is sometimes open telemetry is a bit complex, and that's looking at just the data model, the specifications. So there's a tremendous amount of documentation, working with the SDK, working with the collector, integrating with a backend. We can't. Rotel doesn't solve all those things, but and we're very comfortable with open telemetry. But for developers who are maybe coming to the space and they don't have a long history in observability, with Rotel, we thought to ourselves, what can we do to make this easier for those sort of people who maybe aren't familiar with OTel and the history of observability. So basically, we focused a lot on improving DX, and that's basically simplifying configuration, a lot of sensible defaults, a lot of built-in stuff, and basically bundling with different runtimes. So running Rotel and running a collector is easy as just pip installing a package. And we're going to take a look at that a bit. So, one of the things, a lot of these projects that exist today, they rely heavily on YAML for configuration. So if we're looking at configuration, what we try to do is make that real simple. And instead of going to a big YAML-based config where I'm defining pipelines and sources and processors and exporters, we said, could we do a lot of this out of the box, focus on just basically command line flags, sensible command line arguments and flags, sensible defaults. And if you want to set something, do it with environment variables. So that's the approach that we've taken, because we think declarative config is good, and there's use cases where we want that. But it's kind of like, it leads to like overkill for many cases. So for a lot of use cases where people are like, hey, I just want to collect open telemetry and I want to write it to Kafka, or I want to read open telemetry from Kafka and write it to ClickHouse, they shouldn't have to be building like large configs for this stuff. So running Rotel is like really straightforward. You can just basically pull a container really quick, run it with a Docker run command, and it's going to start. By default, it will listen for OTLP and it will export OTLP to localhost. You can install it with a Python module, a Node module. We also have pre-built binaries, Lambda extensions. So like I mentioned, we have a bunch of pre-built modules and containers. We're going to take a look at that in the demos here shortly. So all of this was focused around trying to make deployment easier for developers and basically be able to shift that left so developers can get going with open telemetry collection and exporting really quickly. And I want to get to demos because I think talk is cheap. So this is an example, though, of the collector basically as code, taking a look at how I run Rotel as a Python package. And this is an architecture diagram of the SDK. But I think it would be more interesting to actually show you some demos in action and as opposed to looking at slides. So let's take a look at that. All right. Let's see. All right, so the first one we're going to look at is running Rotel and Fast API. If you're not familiar with Fast API, it's basically a Python package for writing web services and backends in Python. So here what I'm going to do is just basically start a new project. I'm creating a Python virtual environment, setting that up, and I'm going to install Rotel as a Python package. I'm also going to install the Fast API packages, and next we install the open telemetry auto instrumentation and the gRPC exporter. Okay, once we've done that, we're going to set up a basic Fast API project that just basically has one route. It's a web service. It's got one route, hello world on /. And now we're going to configure Rotel. And we're going to basically do that in code. And this is going to run a separate collector as a process. So as you can see, when you pip install Rotel, you get all the sort of benefits that you would expect from any IDE environment or running an LSP. This is a little config block up here. It's saying, hey, I want to run the Rotel collector. I want to run an OTLP exporter. I'm going to change it in this example to just run the black hole exporter, which basically drops the data on the floor. But we're going to turn on debug logging so we can actually see it in action. So I'm doing that here. And then, yeah, I've got type ahead autocomplete. So you can see I'm enabling debug logging. And then I'm going to turn on debug logging verbosity detailed so I can look at the actual data coming through. And cool. So with that set up, I've got my little basic Hello World app. I'm going to go ahead and start it. If I can remember the command. Okay. So I start Fast API. It's listening on port 8000. And then in this other window over here, I'm going to run Apache Bench. So I'm basically going to, first I look at the Rotel logs. This is a pre-recorded demo. So you can see Rotel's running. It's listening for OTLP. And then I run Apache Bench to basically hit the web service. And you can see this is Rotel's log saying from all of those auto-instrumented traces from Fast API, basically it's coming through Rotel, it's receiving them and logging these out. So that took 2 minutes essentially to get up and running with open telemetry and get a collector going. Let's take a look at something a little bit more interesting. Let's look at actually exporting this data somewhere. So in this example, we're going to keep working off of what we were, the example we were just looking at, and we're going to actually run the open telemetry exporter, and let's send it to Axiom. So Axiom's an observability backend if you're not familiar with it. But it supports accepting traces, logs, and I think they might have support for metrics now. So I've got a little snippet here basically for the OTLP config. I'm going to drop back over to Axiom. I'm going to create a new Axiom data set and create a token. Cool. And we're calling this data set Fast API Rotel. And that's not a glitch. That's actually me editing out the token. And now I'm going to restart the app. And again, I'm going to send it a bunch of requests on slash. And if we go back to Axiom, we can see, boom, we've collected and ingested all that telemetry, sent it to Axiom, and we can look at our traces. So real easy. That took about a minute. And then I got one more demo, and I think we're going to hit the 15-minute mark with that. So the last one is for the Python processor SDK. So this is going to show you how simple it is to write processors with Rotel. So for this one, we're going to create a new project called the email redactor, and we're going to set up our Python virtual environment. And we're going to install the Rotel SDK. So this allows us to write Python to work with telemetry. So in addition, we got to pull down an image of Rotel. So I'm pulling down a pre-built image of Rotel that basically works with a given version of Python. And now we're going to write our processor. So when you install the SDK, once again, you get LSP integration, you get autocomplete. And as I mentioned, Rotel basically works with the internally with open telemetry data types. So you can see here that you're working, for example, if you're familiar with the data model of open telemetry, I'm working with resource logs. So I'm writing a function here, say, let's process resource logs for every resource log. Let's look at each scope log. And then for each scope log, let's look at the log records. As you see, you get hints. You basically get docs associated with the data model. So you can say, oh, log record is, or scope logs is a list of log records, etc. So we're going to create a function here called redact emails. We also need to pull in, it looks like we're missing the any value type. So we're going to import that from common. Cool. Let's see what's next. We also need to import the regular expression library. So we do that. It looks like we got an error here saying, oh, that's right. So log record.body can actually be none in an open telemetry message. So we need to check to make sure it's not none. And then we got an error about missing the email pattern. So I'm going to grab this email pattern snippet, paste that. Cool. So there's our processor. It should redact any email addresses that are seen in logs. So now we're going to restart Rotel. We're going to run it with our processor. So it's restarted. And now I'm going to basically use telemetry gen in this case to send basically OTLP log messages that has an email address in there. It says ray@streamful.com. Let's not leak this pie. And you can see Rotel and debug over here basically redacting those emails. So it's running those processors, that OTLP log processor, looking for any email addresses and redacting them. Cool. Okay, I think that's about 15 minutes.
Awesome, thank you. I had a few questions to be honest, but I will leave it for the panel discussion. So same, if any one of you have any questions about Hotel or the demo that you just Ray delivered a few seconds ago, keep your question noted side and drop it for the panel discussions. We will have a dedicated time for covering all the questions. All right, so let's go to the next session, covering now the visualizations with Percy. Hey, how are you? I don't hear you. Wait.
Yeah, typical unmute stuff. Yeah, I'm good, Hendrik. Thanks for having me here.
So where are you connected today?
So I'm based out in India, so it's 9 p.m. over here, but that's fine. I'm ending my day with purses.
Cool. And yeah, you had some technical issues, it seems so. So that yeah, the god of the demo was not with us today. I have
Yeah,
some problems on my end. It seems that you have some problems on your end.
but yeah, I can point to some of the things. Yeah, I can show you the story, what and how it comes together so that it makes sense.
Okay, cool. All right, so you have then 15 minutes. So I'll leave you. The stage is all yours, and good luck, and see you in 15 minutes.
Yep. So, hey everyone, my name is Sam Pathak, and we'll be discussing about purses today. So, you all might have been using dashboards. So, in the end, you have your observability stack, you have your metrics, logs, traces, profiling, all that stuff that you do. In the end, what you do is have some fancy dashboards, and most of you might be familiar with Grafana because that's something that many of the people that I keep chatting with, including myself, have been using Grafana. Lately, I was actually searching for Grafana alternatives, and also at KubeCon EU this year, I saw in during one of the presentations where Persis was mentioned. That got me excited. Few things why this is different and why I have been tinkering and playing around with this is because one, it is a CNCF sandbox project. Two, it is an open specification. So just like you have standards, so like Prometheus have defined the standards for metrics. Jaeger has defined the standards for traces. Similar to that, Persis made a bold choice of defining a specification for the dashboards, which is pretty neat. Then as I started digging in, I found more and more kind of features in Persis. So first of all, it's open source dashboard visualization project under the CNCF ecosystem. It has something which is called plugins, where you can extend the architecture. Currently, I think the last I read the docs, it supports Prometheus and Tempo out of the box, but it has, like, you can write and create the data sources, and it's a straightforward process that is mentioned over there. Dashboard as code is very interesting thing, which I'll touch upon in the later part of this particular presentation. It is GitOps friendly, so Persis um, itself is there, like you have this Persis server and all that stuff, and then there is something which is a CLI component, just like you have kubectl or kubectl, however you pronounce. There is a Persis CLI, so which is called per CLI, PER CLI. So the per CLI is also there, where you can actually go back and forth, generate JSON out of your Go code, and then apply that to the connected Persis instance out there, and then do vice versa things. So you can do validations, you can do a bunch of other things with this. Another component is Persis operator. I think all will be coming in one by one. So first, let's talk about plugins. So plugin types available, like you have panel, you have data source, you have query, variable, explorer, and you can write and you have the backend with queue for validation. Prometheus plugin includes, for example, there's a Prometheus plugin which is already there. If you have to build your plugin, you have to kind of choose from the available plugin types and write the backend and the front end and all that stuff. So here, what you can do is, for example, Prometheus use data source query and variable plugins. These three are being used. Embedding panels. I have actually seen this, but I'm not 100% sure. There was one, I was there at Container Days previously. I gave a session on 13 Kubernetes hacks. In that, there was this CRD plugin, like CRD plugin for K9s that is coming up, that gives you a CRD view. And there I saw there was a Persis logo over there, and in the UI that comes up. This is interesting. I think they have used the embedding panels. So what you can do is you can actually install the npm packages, wrap them with the providers, and then integrate these observability panels in your UI. So these, like in your React applications, so Persis panels can be embedded in the React applications. This is something pretty neat. I think people are extending their own UI and using this. Now it gives you the standard. We have, as we previously mentioned, like Persis defines the standard for specifying the structure of the dashboard. So for example, we can create a dashboard tooling for the choice and display the Persis compliant, display it in any Persis compliant server. Just as you have you have HTML page and it works on any web browser kind of things. So that's what it actually means when I say it's a specification and you can use it here and there. Interoperability, if you know, like that's where it kind of works. Then you have, okay, yeah, dashboard as code, DAC. And you have the UI. You can click, we'll go through that process. Although the entire demo is kind of broken, but we'll see some parts of demo might work. You never know. We'll try again. So you have dashboard as code that gives you the flexibility of bringing this closer with the iteration of how you version your application. You will be able to version your dashboards as well. So I think that gives you a pretty neat thing. Like you can align updates across multiple dashboards. That becomes easy. Operational efficiency using reusable components, and reduce the implementation and maintenance cost. Currently, there are two main languages, SDKs, that you can use for DAC. One is Golang, very popular in the cloud native ecosystem. Everyone who uses kind of Kubernetes, works with operators, works with extending Kubernetes, they already work with Golang. So Go is there, and then Qlang is there. So these two are there. And then GitOps friendly, so versioning, reviews, and automated rollouts. So it has a concept, like Persis also has a Persis operator. So you can install the Persis operator, and then you will be having the custom resources. So you will be having those CRDs that you can define and have that GitOps workflow. Another type of GitOps workflow can be, let's say you have a dashboard.go file in your GitHub repository. In your GitHub Actions, you can have per CLI that you can install on a particular GitHub Actions instance. And then you can validate that, and then you can apply that to the dashboard. So you can have a different kind of GitOps workflow using the per CLI 2 and GitOpsify it. Yeah, that's the per CLI. So CLI to manage the dashboards and data sources, projects. So these are the three things which we'll see. So first is definitely logging into the dashboard. So you can log in using your key, using SSO. Yeah, it has the SSO. You can log in using Google, GitHub, which is pretty neat. Dashboard as code is a command where you can convert the DAC, like you have a Go file, you can convert that into the JSON, and you can apply that particular dashboard as code file to the Persis server. Then you have the plugins, so you can, and then there is one interesting thing called migrate. It has a command called migrate, and then validation I already told you. So the whole CI/CD workflows that I was telling, per CLI is pretty suitable for that particular thing. Yes, Persis supports migration of Grafana. I haven't tested it fully, so I don't know what breaks and what works. So I think it's something that needs to be used and see how it works and what breaks. But yeah, it does support the migration. So you can import Grafana JSON directly, or you can use the per CLI migrate command, provide the grafana.json file and apply it online. So once you log in to the dashboard, and you can apply that. And then focuses on, yeah, I think the alerts and user stuff obviously won't be there. So Persis dashboard will be there, and you can apply that to the project. So all in all, Persis provides the alternative to Grafana as a CNCF sandbox project. One of the key features obviously is plugin DAC CLI. The main thing is specification, the open specification that I'm talking about. So we'll see now some of the things in action, hopefully in action. Let me show you. This is the Persis operator, first of all. So this is the Persis operator. Uh, it's not that easy, not that straightforward. Like it's typical developer workflow right now. So install custom resource definition using make install. So it's not that kubectl apply a particular link and then everything is installed, but it's there. And then you have the CRDs that will be installed. This is the, okay, these are the advanced command. I just wanted to show you the specification. Yeah, this is the specification. So dashboard specification. So this talks about the specification of the dashboards. You have data sources, variables, panels, layouts, duration. This is the display specification. This is the data source specification, variable, panel plugin specification. So everything is a specification, and everything is mentioned in the spec section of all these things. Now there is you can open something which is called demo.persis.dev. I'll share this link. I know Hendrik asked to share any links prior to the stream, but happens. So this is one link that I want to share, demo.persis.dev. So if you go to persis.dev, you can actually see that if you go here, you should be able to see the demo. So this is the demo. You can log in to this particular demo, and it should have given some metrics over there, but unfortunately it's not giving over here, and my demo is broke. So what we'll do is, it still shows some stuff. This is what the homepage look like. So you can add a project. So we can add is it observable, and add. So hopefully this would work. Yeah, is it observable was added successfully. So this is the is it observable project. It should give you more details, like you can add dashboard and stuff. So there can be two issues. One, it can be my network, that it's not rendering in a way it should have been. Two, there is actually some issue with demo.persis.dev. This is how the stuff would look like. So if I go here, yeah. So this is how the graphs would look like, and this is how the dashboard .go code, a demo code would look like. So you can, like I was mentioning, like you can specify dashboard.go. So here I'm using the Persis Go SDK. Then these are just some of the stuff that is needed from Prometheus, and this is something from Persis itself, like the panel group, list vars, and the plugin. We need the Prometheus data source plugin. So you can see in the dashboard new. So dashboard.project name. So I created is it observable. So instead of demo, I would have to give is it observable over here. This is something that I have created over here. Yes. So it is working. So it's not completely broke. Is it observable is there. You have dashboards. Obviously right now nothing is there. And this is what the dashboard that we want to create. Now we say add a data source. So we don't have a data source, but it says add data source with Prometheus with the proxy. In the UI, how it would look like is, if I add a data source, go to data source. If I add a data source, this is what it looks like. I give this a name. I give this, I need a Prometheus data source, or Tempo, or Pyroscope, or Loki, or and then scrape interval and the proxy URL, like Prometheus tag. If you have the Prometheus tag, the internal service URL, or the external direct access, whatever that is. So that gives you the data source. Once the data source is there, then, and this is what you can do using the UI, but this is something that you can use using the, you are trying to create a dashboard with all these data source and all these metrics over here. Now add variable. So you can say, I want to add a pod. Maybe I have deployed a deployment within a namespace, and I want to create that as a prom vclass, like in the data source as prom vclass, prom in cluster. Now I'm creating panels one by one. So I create for traffic, latency, error, in-flight, latency P95, errors, in-flight request, and all sorts of other panels which I create over here. So I don't have anything right now, but how it works, yeah, this is how it would look like once it gets deployed, and once it has some data. So latency, errors, request, and all these things. So you will have this kind of thing, and you can easily deploy that using the per CLI. Like, I can show you that. Yeah. So per CLI apply hyphen F dashboard. So first is per CLI DAC built. So I am building the Go file into the JSON. So it reads that, converts that into the JSON that can be applied to Persys, and then it applies. Then you can apply. It creates the output.json. You apply that particular JSON, and then it will give you the relevant dashboard that gets created. So you can also have secrets. You can also have variables that can be, I think, see, the variables can be used across the projects, if I'm not wrong. So or it can be global, I think so. Yeah, there was in the documentation it's mentioned. So I think you can use the variables in the project. You can have secrets, you can have roles binding. So it is more of Kubernetes native way of defining the stuff and making things more streamlined. So that's how it is. But there is also, like, if this kind of works, the default dashboard that they have already in place, which is of node exporter, you will be able to see a lot of great metrics in this. They also have a very good blog on creating dashboards that the community has learned, which is a very good read. Interestingly, I came to know when I was scrolling and when I posted this on Reddit that Persys is actually being used by a lot of um, organizations like SAP. Today, one person commented on one of my Reddit posts that SAP has started using. Dash Zero uses heavily Persys. Red Hat uses Persys. So you can see the adoption as well. So it's not only something to play around with, but it is something which is getting a lot of attention because of the features that we just discussed. So that's in a nutshell what Persys is. I'm also still in the exploratory stage and I'm trying it out more and more. But it's a very fancy project if you want to try out something other than Grafana. Yes, it doesn't have a lot many data sources, like 70 plus, 80 plus data sources. So there are some limitations, but it's a CNCA project, community is there. So I would say, like, join the community, kind of contribute over here, and keep an eye on this particular project. It's kind of solid.
Cool. Thanks, Sayan. Great introduction to.
I hope I didn't go
I
over
didn't check
time,
the
or
time. I
I
was
was
because you
on.
were doing the demo, so I was going to look at it. So oh, okay. So next we have Nathan. Yeah, we'll see how it goes. But yeah, great introduction. I have questions. In fact, I have a lot of questions. I don't know if you will answer everything, but let's cover them during the panel discussion, because there's a lot of things to cover, and I think Percy is a really interesting project and needs to be promoted out there for sure. All right, so let's cover the last session of today, covering more the analytics and analysis of your actual test data that comes in the recession, and this using LLM. So let's go to the last session of today. Hey Nathan, how are you?
Doing good. How are you doing?
Great, that was great. And then I just you just made me bug. I was talking to Sayan and I saw the private chat, and I said, and it just made me freeze. But yeah, I hope everything goes well. So where you connect? You're connecting from where?
I'm calling in from Israel. Me. I think what you're referring to is in the private chat.
Yeah.
I actually just got a notification on my phone. We might have an air raid siren going off about
Okay.
about a rocket attack, but we'll manage. That's fine.
Okay. Hope that nothing will happen for sure.
Yes,
Cross the
thank you.
fingers. All right. So I've seen we've been discussing about HomeStreetGPT. That was a few months ago. I looked at it. I think it was very interesting. And then you presented HomeStreetGPT during one of the tag, the new version of the tag observability. That was I don't remember if it was after the summer or before the summer, but yeah, it was there. And I think it's a great platform, so people should be aware of that solution. So all the floors is yours. So you have 50 minutes to make us dream about HomeStreetGPT, and we touch base.
I give the one-liner. It's Cloud Code for observability, and it's becoming a CNCF project.
Yes, that was something I was hoping that you were going to say that, for sure.
Yes. It's already multi-vendor. So when we started, it was us, by which I mean I'm from a startup. I'm a co-founder at a startup called Robusta. So we develop a commercial platform on top of this. So it started as a single vendor open source project, and now there is a second vendor, Microsoft, that is contributing as well, and maintainers, and also have governance of the project. So already multi-vendor project. Microsoft is using this and rolling this out for AKS Agent, which is HomeStreetGPT under the hood with some additions.
I wasn't aware of that.
Yeah. So we're slowly becoming, there's more places and more stuff coming too. I can speak about the Microsoft one because that's public already, but really exciting times for us and the project and the community. We have people already using this in production. We have people who we have saved 3 a.m. when others are going off. We've been through some, we have customers in certain industries that are highly seasonal. So you imagine industries where you have a sudden spike of traffic, where your traffic can go 10x in 60 seconds. So there's some customers already using this in those situations when others come in, they need to respond really fast. So really excited about where this is going and the ways people are using it already. And I'd love to maybe show you a demo of why and how you can get started. Everything I'm going to show today is open source. So everything that I'm going to show you is going to be part of the CNCF submission, and you can try out yourself really easily. So let's get started. So I'm going to start with just a really quick overview. You got a bunch of observability data. We support a whole bunch of different providers down here. You got cloud infrastructure. You got a bunch of other data sources. This is all batteries baked in. So you can bring your own MCP servers. You can bring a bunch of other stuff. But we have a whole bunch of integrations out of the box that we've tested that work really well. So you have all your observability data. And essentially what you want to do is you want to say, why is this alert firing? Or why are customers complaining that the website is slow? What is wrong, or what's wrong with this application running on Kubernetes? You want to ask questions of that nature. So essentially, AI HomeStreetGPT is this AI agent that sits between the users who have problems and between the answers, which are in your observability data. And it's an AI agent or an AI SRE that goes off and investigates for you. So that is the high level overview of this on the architecture and how it works. You got a large language model. You give an API key for AWS Bedrock, for Azure, for Anthropic, whatever you prefer. You plug into the AI agent. You connect it to some observability sources, and it goes off and investigates stuff for you. That is the high-level picture. Let me just show it to you. So let's dive right into a demo. So I have here a Kubernetes cluster, and you can see kubectl get pods, grep, Redis. Probably need to take all namespaces. Okay, yeah, I have some Redis pods running here that are in pending state. So the first thing I'm going to do is really easy. I'm going to say to HomeStreetGPT, why is Redis pending? And I'm using this as a CLI. So HomeStreetGPT works in several formats. There's an HTTP server. There's going to be a Kubernetes operator. There are a whole bunch of ways that this is used. The simplest one is the CLI. So, okay, I've asked it, why is Redis pending? And it starts by coming up with an investigation plan. So first item in the plan, find Redis pods in the cluster. Okay. Second, check their status. Third, look at node resources, any other issues. check configuration, analyze any resource quotas. Okay, great. So it's going through the plan, and it'll update that plan as it goes and as it learns. Okay, it's done. So the pods are pending due to missing storage class. Redis uses a PVC, persistent volume on Kubernetes, that references a storage class that doesn't exist in my cluster. And that is why it's pending. And then it's gone off and checked which storage classes are actually available so that I can fix this, and gives me recommendations for the exact command I could use to fix this problem. So this is a kind of Kubernetes-shaped problem. I have like a pod that's not pending. Maybe I'm on DevOps team and there are a bunch of application developers and their pods aren't working properly, and they're coming to me, Natan, why is my application pending? Why isn't it crash loop back off? Throw the AI agent at it. 60 seconds later, you have an answer. This is really a simple, trivial example. I want to now throw Holmes GPT at something that is substantially more complex and a little bit closer to the way people use this in the real world. So let's go over here. Imagine that I run an online store, and on my store, you can, the grand tradition, you can buy socks. So I have an online store. People go, they like add socks to their checkout cart. They go, they hit the checkout button, they swipe their credit card, they buy socks. I have a whole bunch of users that are very happy buying lots of socks, and they're thrilled, good for my business. Suddenly I start getting complaints from some users that they can't buy socks. And those users say, like, I'm trying to buy socks, the page just keeps on spinning forever. It's like not loading, it's super slow. It seems really strange. And like my engineers look at it a little bit and they go, well, like, so, I don't know, it's working for us. Like, we just bought socks. Some of the other users are buying socks. Like, it's only affecting some subset of the users. I don't really know why. Now, behind this, I have some checkout service that's running. Maybe it's a microservice on Kubernetes, and it is backed probably by like a bunch of other microservices. There's maybe a database there. There's maybe some other stuff. Usually, or like 2 years ago, I would have showed you a whole nice architectural diagram of the whole microservices architecture and how everything is connected. Today, I don't need to. So today, I can just say, like, there's an online checkout service. Some people are trying to check out stuff. Some of it is working. Some other people are getting errors. I don't even care what's behind it. Like, that's why I have an AI agent for us. The AI agent figure out this problem. Okay, so let's go back to Holmes GPT, and let's say to Holmes GPT something like, why is there high latency in the checkout service? Or like, why can't users buy socks? Or why is it going slow for them? However you want to frame this. And I'm going to run that. And I went in advance before this demo. What I did is I connected Holmes GPT to a few different observability sources. Probably the most useful source for this investigation will be trace data. While this runs, we'll check back in just a second. We have docs. Go to the docs. We have a ton of different data sources built in. You can, of course, connect MCP servers. You can connect a bunch of other stuff. One of the data sources that we have built in is Tempo. So today we are using this Tempo integration. I have some other integrations connected too, so we'll see what AI agent decides to do. Sometimes it surprises me. But probably to say why people can't buy socks online, you probably have to look at trace data on this checkout service. Okay, we're going back to the investigation. You can see it's investigating high latency in the checkout service. It's broken this down to tasks. So first it's going to find the pods, then it's going to look at trace data, look at metrics, CPU memory utilization, look at the logs for any errors, look at downstream dependencies, upstream dependencies, downstream services, check out a bunch of other stuff. It's going in and it's doing that. Okay, fantastic. I have the response. This is actually really interesting. So remember we said some users can buy socks online. Some users can't buy socks online because it's super slow for them. So what's interesting is the pattern that it's telling me here. There's a performance pattern. Normal requests take 102 to 200 milliseconds. Requests with a promotion code take 1.3 to 3.5 seconds. Here's the statistics on that. So some users are going online and they're buying socks and it works well. Some users, and I remember I did a post on Twitter, or what is it, X now? I did a post on X and I put in there a promo code. So apparently a bunch of people took that promo code, but something is in my application is probably not handling that well. So when there's a promotion code and people are using that promo code, the people who are using the promo code are having a bad experience. So like people are trying to buy socks. The agent saying for most of them it's fine. Some of your users are giving a promo code. When they give that promo code, then the requests go really slow. But it didn't stop here. It went on to understand why is that the case. So it looked what is unique about those requests with the promo code, and it went through all the trace data. So pulling all that trace data, started looking at the traces, started looking at the different microservices, and it found something really interesting. When there's no promo code, then the application ends up doing this query on a Postgres database. When there is a promo code, so someone has like a coupon for Black Friday or whatever, then the application does this query instead where the promo code is included. That's fine. And it looks like we're missing an index on that promo code. So it's giving me some recommendations how to create the index on the database that will actually make this go fast. So what we've seen here is I can take a problem that I'm getting from users complaining about bad user experience, a customer experience problem, really, customer satisfaction problem. Your application is slow. Why is it slow? Well, my team invested a whole lot in instrumenting that, sending all the data. Right, Ray spoke about that. I have visualizations, I have alerts. I probably look at the Percy's dashboard, like Sam spoke about. I see that there's a spike in latency. Why is it happening? Where is it coming from? So Holmes GPT took it, it analyzed it, it found a pattern, found out which subset of the users are having a bad experience and have this slow experience. Then it took that, it deep dived into that, double clicked on it, and figure out exactly by tracing through the microservices exactly where that problem was coming from. So it was able to find here that that problem is actually coming from a missing database index, and to give me recommendations on how to fix that. Of course, AI is not always reliable, so you want to see the data it relied upon. So I can go right here. I can say like, okay, show me the data you relied upon. Here I can see all that trace data. I can look through it myself. Can query data from Prometheus. You can have it show you the proof that backs up the exact data that is saying, or give me a link to go and look at that in Percy's or in Grafana myself. So this is just one example of the type of stuff that Holmes GPT can do. To do this, you really have to do, there are two prerequisites if you want to try this out. One, you need a good model. So I'm using here a model. I'm using Sonnet 4 from Anthropic. You can use Sonnet 4 from AWS Bedrock as well. That is the model to use. We've done extensive benchmarks. We have a ton of benchmarks around this. Sonnet 4 consistently gives the best results, better than GPT-5. So if you can use it, my recommendation is to use Sonnet 4. And then part 2 of getting good results is you have to hook up the right data sources. If I didn't hook up Tempo, then I wouldn't be able to get good data sources because Holmes GPT wouldn't be able to see any of that trace data and give me the answer. So connect metrics, connect logs, connect traces, and you should get really good results when you throw this at real production issues. And that is more or less it. How am I doing on time, Henrik?
You're doing fine, to be honest.
You're on
I'm
mute.
just looking at because we started late due to technical issues. So I think if you can start conclude, so then we have more time to discuss, will be better. Otherwise, we will we will end up the live stream a bit late.
The debate. What I was thinking of showing. I'm not going to show this then. I'm gonna say exists, and then I'll leave this as an area that people can dive into more if they're curious. We also do extensive tracing on this. So if you're curious and you want to see what OpenGPT is doing under the hood, you can go over to you can enable tracing, and then with a system here I'm using a system called Brain Trust, but there are a ton of tracing systems. You can look at something and you can understand what Holmes is actually doing under the hood. So you could go over here and you can say okay, show me exactly which tools it's gathering, what data is it gathering, where is it gathering that information from, and so on. And you can do a deep dive into what is actually happening under the hood. If we had more time, you could walk through some of that and show some examples. But I just want people to be aware that it's a really powerful tool to trace the LLM, to understand what it is doing under the hood, what data is it gathering, why is it gathering that data, and that can be a really powerful tool when you're if you're building systems like this. For end users, it doesn't matter as much.
Cool. I love it. So let's jump into the panel discussion because I have several questions to you. To be honest. So I will ask them directly on during the panel discussion, but we'll follow the order of the speakers. All right. So let's join everyone for the last section of today's live stream. First of all, amazing job, guys. You did pretty well, even if you have some technical hiccups in the call. I think it was a good session. Even Sayan, if you didn't have a demo, you were able to explain everything and show you things. So good job on your end for that, for sure.
It's working now.
That is always, it's the power of IT sometimes. Yeah, whatever you name it. All right, so I will. If by the way, if anyone has questions about the session so for each session, so each speaker, we will start with Rotel, then followed by Percy, and last Homes GPT. So if you have noted during each of those sessions any questions, please drop your questions in YouTube, LinkedIn, basically where you're connected. And of course, we will try to answer to all your questions. But let's start. So Rotel. So I saw Rotel, and when I saw your first the first piece that you showed us, Ray, I said, okay, interesting. You're adding a process into a Python. Are you currently working on an operator or maybe for new releases of Kubernetes like 1.34, like a mutating policy that could basically inject like your sidecar to avoid forcing user to add in their code an extra layer for the collector? So what is your currently solution as of now to deploy Rotel in an easy way for users?
So you're coming at this from like a Kubernetes perspective?
Yeah, I'm very much a Kubernetes geek, but I'm sorry. Maybe you can also think about the Lambda story as well.
Sure. Yeah, and I've run Kubernetes at scale in a lot of places too. So I mean, I do think about that, but it's interesting just the context of things. So when you look at that example, like for the Python package it's called PyRotel, right? And so you have Rotel, which is just a binary. It's a single statically compiled binary, right? There's this package where you can say in Python, hey, I want to run Rotel, and it figures out what your architecture is. It installs that, and you get the separate binary. And if you're running in an environment where you're not in Kubernetes, like say, and that's the point of this, I think more so, like say you're running a railway or you're running on Fly or something like this, and you don't want to go through that hassle of like connecting a sidecar, running a sidecar, configuring it, connecting it, SDK point here. It just does that really easy for you. So if you want to run Rotel though in Kubernetes, super simple. We publish Docker images for it. You can just grab it, configure it like you would normally, right? Any other. So say you're running a hotel collector or vector or fluent bit, you'd run it the same way you would. And you can put the config in there. It's environment variables. So you're going to be passing those in as environment variables, right?
Okay, and then if I was thinking, because you showed us like you were building like a Python with a Python SDK, like a processor. So
yeah.
So the question is, if I'm shipping it in a Kubernetes, so do you have like a section, like a specific CRD or something to say, here is my code, deploy that binary and add that extra processor on top of that? Or how does it work?
Yeah, how I've done it is just basically mounting. Like today, I've just mounted the volume. So I'm like, oh, I have a volume, and I'll mount it and say, okay, I want access to this. Or if you want it all in your container, you just basically say, hey, I'm going to build, like you build your container, you have a Docker file, and you're like, hey, I want Rotel, and here's the actual processor scripts I want to run, and you copy it and build it. Just like you would if you imagine you had like you deployed a version of the Open Telemetry collector and you copied the config in or something like that.
Okay.
Similar sort of structures.
And my last question would be, from my perspective, I think because you don't have the full-fledged plugins that the collector has as of now, so it's basically designed to receive the data, do some very minor transformation, and then sending to a destination. So it could be another collector, the Open Telemetry collector release. And so for you at the moment, you're mainly targeting Rotel as a edge collector that sits in the Lambda or very close to your code without eating resources. This is how you're pushing it. You're promoting it in a way. And also, I just had a question coming up in my mind. Does it expose metrics as well? So there was also another question.
Yeah, it exposes metrics and also open OTLP and OTEL metrics basically exposes them. Some people have asked for trace. It's the same problem as the collector where you have a, or yeah, so it's picked up the most traction, I'd say, in the edges due to the efficiency and how quickly it can start. Cold start time is important in an edge environment, particularly in Lambda where you're getting charged for how long it's running. But a lot of people have run it at scale in various places, whether it's on the edge, whether it's in a middle tier or even as a gateway tier, and the performance is quite good because, as you can imagine, it's bare metal performance with Rust. So it depends what you're doing. In terms of the scale or the scope of the number of exporters and ingestion, we have far less receivers than the OTel collector. I mean, it's Kafka and open telemetry today, right? And far less exporters. So for certain use cases, it's really great on the performance side, obviously. So like reading in from Kafka, writing the ClickHouse, things of these natures, very, very fast. So
cool. Sam or Nathan, do you have any questions for Ray?
So it's interesting. I don't, but it's like I've lived for the past 4 years on all of the what do you do with observability data after it's collected side, and like built so much in that space. And then like now as we ramp up our production, it's like for the first time, like because we also do a lot on premise, so we don't have to worry about that with our typical customers. But now like our SaaS platform is ramping up, so like for the first time we're actually dealing a lot with how do we actually ship some of that data ourselves. But for the past 4 years, I've been like so much focused on the other side of this. But we might have some internal use cases for this in the upcoming months, I think. So it's interesting.
It makes sense. We're hearing the same thing. Just in terms of when you think about like adoption of AI and LLM and agentic workloads, the volume of data is only going to increase, somewhat potentially exponentially. You have, machine data has always been extremely high volume, right? Now, if you have machines creating more machine data, imagine I've got an agent, it's spinning up some sort of cluster, it's running a workload, it's generating tons of logs and traces. You're going to want something that's extremely fast, pretty lightweight, to be able to process this data. So when we started Streamfold, the company that builds Rotel, that was core to our thesis, was essentially observability costs is probably the number 2 thing right now behind your cloud infrastructure costs, and that's only going to grow. The amount of data, telemetry data, is just going to grow massively. So having an efficient, solution there is important.
Yep, agree. Let's move on to Percy. So Cyan, I have a few questions to you. I've tried out Percy, and I tried the operator and the CRD that was that I was using, or at that time there was a lot of reference to the positioning of the various graph in the screen, and I thought, okay, so I have no idea how to position that graph. So then I realized quickly that you have to follow the way of doing as code approach in other vendors, or Grafana or Dynatrace or others, where you start from a graph perspective. You start building manually with your you're clicking on the UI, you're building the dashboard, you're pulling the different panel, and then you export it in a JSON. So then you can have a reference of the various areas where the graph will be located. And I thought, I mean, I love the project, but I thought I wanted to resolve that pain of having a graphical reference. And it seems that on your demo that you did on the code, when you do with the code perspective with the Go language, you don't have to put X, Y, Z, whatever. So my question would be, does the operator now remove this reference of the positioning on the screen? And then if not, would you recommend to use the code to avoid having this pretty much stick to the UI positioning? What's your opinion on that?
Yeah, so I haven't used the operator, so I don't know where it fits in as of today, but I have used the per CLI to directly generate out of the code. So it's pretty straightforward. You use the SDK or QLang, write all the, like, give it the project name and the data source, these two things, and after that you just codify your panels and graphs and all that stuff, and you create a JSON. It automatically populates the graph for you. So I think that's the workflow that I have done, and it works in a seamless way. But I'm yet to try the operator, and maybe it has some limitations.
Okay. And the other question I had is like there's another great initiative, because here the main data source that is currently available is mainly the Grafana stack. So Prometheus, Loki, Tempo. There's no other data source there. And I was thinking, okay, so if I have a data source, then we are using the query language of the data source to pull out the data. So then if I have a graph mixing data from Prometheus and data from Tempo, or no, not Tempo, from, I don't know, Jaeger or something else, then I need to have different dashboard with different query language. And I know that there's this working group in the observability, all the tag observability, that was the unified query language approach. And I thought that maybe Percy plus this common query language would be a great fit, because then Percy is not query. The query language of Percy is not related to the backend, but to a general whatever language that we could rely on, and makes the usage of data source more smoothly than having to learn each individual data source. So, do you know if there is anything on that regards, or what?
No, I haven't seen anything, but I know that the tag observability was, like, it was part of the restructuring, and it now falls under the tag operational resilience, and the unified query language has definitely come up within our tag. So now the charter is approved, so the tag operational resilience charter is approved. Next step is the sub projects. So sub projects and initiatives. So these ex observability projects that were very highly contributed, they'll start coming up as sub projects, and we'll see some acceleration in that particular
Cool.
side.
Okay, so maybe some future improvement will come up if this query language
Yes.
has made some major improvements. Cool. Nathan, Ray, do you have any questions to sign?
Can I get Holmes to basically write me some Perseus code so I can just automate that one?
So it's
So you probably don't
Yeah.
even need Holmes. You could probably just do that with ChatGPT or Anthropic. Like, our advantage is connecting it to live data sources.
There is,
Sure.
sorry to interrupt, but there is an MCP server that there is a MCP server for Persis that they launched in July August timeframe, and you can actually now query and stuff using plain English, or using your Claude, and use that, add the Persis MCP server with the configuration, and you should be able to do something. I haven't tried it, but I read it that they do have the MCP
Okay.
server.
And you can plug that into Holmes, I guess.
Yeah. This is a problem that's been around forever. And when you think about one of the promises of open telemetry is like, cool, I've got a vendor neutral format. Now I can try out different backends. I can move really quickly. One of the problems, like, I've seen working in this field, like, Librado, for example, is like, it's a major lift for the company to switch all these dev teams, all your teams, switching from dashboard to dashboard, systems to system. So it's really exciting if more vendors adopt this. It's going to be super easy. What's the story? And maybe I missed it. Is there a story with Perseus? Anything related to like alerting, like Grafana Alert Man? Can I move alerts between systems? Like the definite. Is there a plan or any thoughts around that? Because that's usually a big one, I think, as well. Moving alerting.
I think alerting is not supported. So they have mentioned in their migration document that alerting is something, but there might be some works. I don't know. But right now in the current migration, when you do the Persis migrate command, per CLI migrate, it does only the UI to the graph to graph kind of migration rather than the alerts and users. These both do not come.
Okay, that's and then the query at the end is Prometheus, so it doesn't change much.
Prompt
Yeah.
to it, yes.
One thing I need to I forgot to bring it up. I need to. So for those who wants to get details about Rotel, fully forgot that. I'm sorry, right, for this. So for those who wants details about Rotel, here is the link to rotel.dev. Check it out. It's you could get a lot of details and how to get started and so on. And then if you want to interact with the Rotel community, there's a Discord channel, by the way. So here is the QR code to the Discord channel of Rotel. If there's any questions, I will move to the last session of the day, which was Holmes GPT.
Wait, one question first, just
Cool.
on the alerts. I feel like the ecosystem, like the proper ecosystem way to do that, or the way that I see some people doing it, is using the Prometheus operator, which is then super complementary. So then you're doing like dashboarding as code with CRDs. Again, we're all like in the Kubernetes bubble for a second, but like then you're using the Kubernetes operator CRDs to define your alerts. I think it's like a Prometheus rule CRD, and then you're using like the Percy's CRDs to define the dashboards. But I feel like it's two fundamentally like different concerns where you might want Percy's to visualize alerts that are coming in. But like if you're taking that as code approach, then like the definition of the alerts like already has a good like open source CNCF solution there, which is the Prometheus operator.
I mean, the operator is brings you the storage layer, the Grafana UI, and the various exporters to visualize your Kubernetes cluster. So, and also if you depending on how you deploy it, you get the config maps holding the various dashboards and the various alerts and everything. So then when you open your your Grafana instance, you got everything plug and play. I may assume, I have no idea, I didn't check on the actual repo of Percy, but that they may have like a similar onboarding process for KubeStack. I don't know. Sain, do you know if they have something on using their operator when you deploy like a modified KubeStack Prometheus Helm charts that includes everything?
I think Nathan has done some work on that. Modified. I remember last time when we had a chat, a minified version or the version that you actually need instead of the heavy bloated version.
Yeah, we haven't done it with Percy's, but like we ship to customers optionally a modified Prometheus stack. So I imagine what you would do if you were like a user wanting to go down that route is you would disable the Grafana component in Prometheus stack, and then you would enable Percy's as a separate Helm chart. You would probably have an umbrella chart that includes both of these, and then you would just like add a webhook receiver. Again, I don't think Percy's today can actually receive the alerts. And then
no, I think it's just that you need to change the data source with the Prometheus. Yeah, and that's and I think that's
yeah. Okay, I was thinking more in the alert flow.
Yeah.
It has a feature of data source discovery, which I haven't read what it means, but it has some feature of data source discovery too.
So if anyone is connected and are using Percy's and know how to do this, please drop a comment to us. We will be very interested about how you're doing this for sure. All right. So last session, Holmes GPT. So on Holmes GPT, I have a couple of questions. So first, so you mentioned that you need a LLM system. So you said Anthropic, or you could use I remember the other one what you were referring to. And then I said, because at the moment I'm trying to do everything on my lab perspective, and I'm starting to get a machine, set up Olama, put a big model on it, and then have this API available from Olama perspective, and then use it as a core LM system. Do you support Olama? That would be my desire.
First of all, God bless you. And second of all, technically, yes. What I mean by this is you can run Olama and you can point Holmes GPT at Olama. I've done this. I've done this with the GPT OSS models. I don't have a PC, I have a potato, and on my potato, when I on my laptop when I did this, I went out while I was waiting for Olama to do the inference. Like I went out, I got lunch, I came back, I looked at the screen, I went and got a coffee, like did a bunch of other stuff. I came back tomorrow and like maybe there was a reply. I could not get it working well. Homes GPT is token hungry. Like Homes GPT likes
it's going to consume tons of tokens.
It likes to gather data. It likes to consume tokens. It likes to generate tokens. And that makes sense because observability data is infinite. There's like a ton of work that we've done on getting Homes GPT to not use up an entire context window on a single query. So like we can query a whole bunch of stuff and like bringing observability data and then rewrite the queries if there's too much data coming back, so you get a subset of it and sample. Like there's a ton of work that the team has done just on not filling up the context window because Homes GPT is token hungry, and that's how you get good results.
But that's a good point. So are you instrumenting, because you were showing the traces? Are you producing also like open LLMetry traces on the consumption, so you can keep track on the token usage and the quantity of input token and output token, so then people can somehow estimate, so say, oh, it's great, but it cost me 1 million since I'm joking about the price. Yes. But it's just that it tokens at the end after significant usage is also a cost at the end. So I was wondering if you also keep track on that.
Yes, so you can, first of all, in Homes itself, in Homes itself, you have here like slash context, and you can get information on like the context window. I don't think we have a dollar amount in here. I think we're only showing token usage, but you can get all the information over here. And then we also allow shipping some of this data to Braintrust, and we have a request to support like OpenTelemetry in broader providers. We use Braintrust ourselves, so that's why we ship there. But you can get out the trace data as well. And if anyone wants to open a PR for other providers or to make it like fully OTel, OpenTelemetry compatible, then please do so. And then the final way is we run extensive benchmarks. So here is, these aren't public yet, but they will be soon. Here's a benchmark like comparing GPT 4.1 with Sonnet 4. So the average cost, like if I look for a second at the average cost for a single very complex question comes out to be around 15 cents for Sonnet, and then on GPT-4 around 10 cents. Max cost is like 41 cents on Sonnet.
And do you look at the accuracy of the response? Because you said that, I think you said Sonnet was better than GPT-4.
Yeah, the numbers are misleading. This is why we haven't published the benchmark yet. We're trying to wrap it up in a way that will be more clear to users and not misleading. Here are the results on that. So here's the success rate. The reason that this is misleading is because imagine, like according to this, Sonnet is 12% better. What does that actually mean? So imagine a simple world where you have 10 benchmarks. 8 of your benchmarks are really easy. It's like, oh, why is this pod crashing? 2 of your benchmarks are really hard. You have to like look at a microservice, then look at its dependencies, and look at the dependencies on that, then look at those dependencies. Like you have to sift through a ton of observability data and do a really complex investigation. So imagine a world where like GPT-4o gets all 8 easy ones, it gets none of the hard ones. Sonnet gets all the easy ones and it gets the hard ones. And then you look at the numbers and it's like 80% versus 100%. You go, oh, like Sonnet is 20% better. What does that actually mean? It means on every complex real world use case, GPT-4o will be useless and Sonnet will be fantastic. So like the percentage here can be misleading. So what we're starting to do is also to break this down by like different groups and to be able to say like, okay, on problems related to logging, how is that different? Or on chain of causation, that's like those examples where you have one problem that's caused by another problem that's caused by another problem. How do each of them do?
So traces is 0%. Wait.
No. So traces is so this is also part of it. We have trace examples. They're actually they're being skipped here due to a setup issue. And then there's one here where it's failing. If I go down on the trace data.
I think Cyan has to move. He has another meeting. So Cyan, thanks a lot to be connecting to tonight. Observability Live Talk. So have a very nice call. Enjoy your night call, and talk to you soon.
Thank you. Thank you
See you.
all.
Bye.
Bye.
Yeah, so traces is not 0%, but there's like setup issues with some of the tests. We're still working on getting this in the format where we can go off and we can publish this and people can use it to make good decisions about which models to use. Right now, I think it's more confusing than it is helpful if you don't have all the context. But in the next week or two, we're going to be making this public once we clean it up and like add explanations on what everything actually means.
Cool. And the last question that I had was more about you didn't mention you focus on the CLI for and then because I think you're also a web UI, but also something that when you showed me a couple of months ago, it was more the plugin that you have with Slack, with the Slack bot. So I think that using it through Slack, I thought was super powerful because I mean, I like the web UI for LM, but sometimes you want to have it more integrated to your workflow. And I think Slack is a wonderful example. So what's the do you just have to turn on an MCP with Slack, or what is the journey if you want to do this?
Okay, great question. So there's there's 3 Slack integrations. First Slack integration, we have a walkthrough on this. You just run the CLI, and then you pass a flag with like the Slack channel, and it sends to that. So here's an example. Here is an example from the docs how you would like integrate this in a CI/CD pipeline. So imagine you're like you have a CI/CD pipeline. At the end of the pipeline, say pushing something onto Kubernetes or it's doing a Helm install or Helm upgrade, right? And then it fails. So like as part of your CI/CD pipeline, you might want to run Helms in the CI/CD pipeline. So you say like, okay, this deployment failed. Go and investigate why. And then you pop in over here, destination Slack. You put in the Slack token, you put in the Slack channel, and then like now every time your pipeline fails, you just get a message in Slack with the results of the investigation. Okay. So that's the first integration here. The second one is there's a Slack bot. This is part of our commercial offering, but there's a Slack bot where you can like tag it as like a team member. So you tag it in Slack, and it's like an interactive two-way discussion. And then the third way, let me just pull it up on screen for a second. Give me 1 second, and I will show it here. Yeah, okay, perfect. The third way is not out yet, but it's already in kind of public-ish alpha. It's on GitHub if anyone wants to check it out. One of the things that we're doing with Helms is turning it into a Kubernetes operator. And what that means is they'll be able to run in your cluster, and there'll be 2 CRDs. There'll be like a Helms check CRD and a Helms schedule check CRD. And on the schedule, you can have it periodically check for problems and then report them to you in Slack. So
I was going to say that. And there was something else that brings me to my last question I had, because when you have an incident or when you have a problem, you like to run post-mortem analysis, say, oh, I have an issue. You find the problem, and then you want to save for later the discovery of the issues and reuse it. Would there be a future where Helms has like a sort of RAG, where when you have a good solution, then you want to export it to the RAG, so then next time something appears, Helms GPT is not starting from scratch. It says, oh, I know that issue. It happened last week. And that was the problem. So then you don't have to consume 200 or 300 tokens, whatever the question. But have you already thought about that improvement?
You can do it today with an MCP server. So you connect like MCP servers to read from your Slack chat history, or your workspace history, or from your postmortems. You can do it. You need to be cautious with this. So this is actually one of the things that we discovered when doing the benchmarking, is that you actually want to you will sometimes get better results by not including any of the historical data. Because when think about yourself, like if you're on call and you get a call from your team leader, for someone who's been at the company for a decade, and he says there's a problem, there's this alert, and last time we had a problem, like look at X, Y, and Z, right? Last time we had this problem, it was caused by such and such. Well, the first thing you're going to do is you're going to go off and you're going to check such and such, right? But every problem is unique. So that actually can take the LLM down paths. We've seen empirically that by kind of priming the discussion and giving it directions that we think are relevant, you can actually decrease the accuracy, even though at first glance it seems like a fantastic idea. Like, what if you don't prime it? Many of the cases where we thought it will only find that answer if you're putting in like all this specific information on the postmortems, we found it can actually find on its own.
I was trying to find a way to reduce the consumptions of token, and then if you feed like a local, like a RAG, local RAG that you store in your cluster or somewhere else, then take advantage of that data. So then yeah, you reduce the need of going through large language models.
Yeah, so it's gonna be. So we have some ideas around this. Like, one idea is, let's say an alert comes in. Let's say you get an alert firing, then you like do a hash on the labels on that alert, or you have the LLM pick out which labels of that alert would be a good cache key, and then you like can create like hashes on what data should actually be gathered. So like when an alert comes in, you don't gather the data. When an alert comes in, you calculate a key for given that you use to figure out on similar alerts when you gather data. So you can like use LM to generate rules that you apply in the future. So there are things you can do with this, but today to get the best results, you should just throw tokens at it. And honestly, like if you're running this for home labs and for as a hobbyist, it's different. But if you're running this in production, like the cost
of course,
of an incident is so high, like what's $1 in tokens?
No, I know. It's just I was more thinking from that perspective. I'm looking at the time, so it's already 1 hour and 31 minutes of live stream. Oh, I think we beat the record of the duration. Gosh, sorry. Sorry guys, it was too long for you. Hope you enjoyed at least the session. So thanks, Nathan. I didn't cover all my questions. Ray, I think you have a hard stop as well. So thanks, Ray, for showing us Rotel. All the links will be added to the video. So if you didn't have the chance to join us at the beginning and you missed one of the talk, don't worry, it's going to be available anyway in YouTube. Thanks, everyone. Thanks for coming in. Thanks for joining us live for this Observable Lightning Talk of September. And yeah, let's conclude. If you enjoyed this session, like, subscribe, hit the bell icon, and see you soon from another Observable Lightning Talks. See you. Bye.